is a reflection over the line y equals x, and we know from this that it switches your pairs around. All your domains and your ranges also switch around. Remember doing this for exponents. If we had your exponential curve, and we reflected this guy and got your logarithmic curve, remember your domain was all real numbers, and your range was 0 to infinity. When we swap these around, this became your domain. This became your range. So it's going to keep the same attributes. When we do a trig inverse, it's going to be the same. The only problem is we're more like the parabola. We have to restrict part of it. We can't use that whole parabola because it's going to fail the test when we take its inverse. So we're going to define your functions and work on your functions first. So the first one we're going to do is your sine curve. We're going to use your sine curve. I want to see if I can fit this in here. Okay. First step. Let's go through your sine curve. Once we do one, they'll kind of make sense. So graph this with me on this paper. Do you have the same paper that I do? Yeah. Okay. So graph this with me. Okay. Is this a function? Does it pass a vertical line test? Yes. So yes, this is a function. We said this is our sine function. Does it pass a horizontal line test? No. So we cannot get a true inverse until we limit this domain to where it will pass a horizontal line test. A long time to get to your locker and back.
Oh no, I have to find it. I can't find it.
All right, now, we always start with quadrant 1. Isn't quadrant 1 from 0 to 90? Everybody's quadrant 1. And isn't everything positive in quadrant 1? So now, we start with this quadrant. If I traveled up here, as soon as I go to turn, oops, I failed the horizontal line test. So I'm going to cut my curve right here as soon as I fail. As soon as I fail my horizontal line test, I cut my curve. Now I'm going to back down my curve all the way back here. Whoops, I got to cut it again, or I will fail a horizontal line test. So my restricted domain for sine says from negative pi over 2 to positive pi over 2. Wasn't our domain before all real numbers? All, we can use anything for sine. Well, if we're looking for an inverse, we have to restrict it. We can only take that little piece, because otherwise we fail. So now, see if this makes sense to you. This is quadrant 1. In my circle, if this is where my positive 90 is, where's my negative 90? What quadrant would I be in? 4. That would be my negative 90. This is quadrant 4. So I can actually use my negative 90 to my positive 90. So I'm actually in quadrant 1 and quadrant 4. Reversed, obviously, quadrant 1 / quadrant 4. Okay? Now, what does this mean? When you looked up the sine of 30 and it was positive, which one did you get? Quadrant 1. You only got one of them. Are we able to use quadrant 2 where the 150 is coming from? Nope. Remember when I said find me the sine of 150, and the sine of 150 is also positive 1/2? But that's not in our restricted domain. This is now our restricted domain. Your range didn't change. Where does my range go from still? From this little piece to this little piece. Good. Okay, so for sine, we have a restricted domain.
What does that say under the negative 5 over 0?
It's quadrant 4. Quadrant 4, because if we look up negative 90 on our unit circle, doesn't negative 90 force me this way into quadrant 4? And isn't this all repetitious? It goes 1, 2, 3, 4, 1, 2, 3, 4. Don't I keep just going around my circles? Right? So my domain is going to be restricted to quadrants 1 and 4. So whenever you see an arc sine or a sine negative 1, you're automatically in quadrant 1 or quadrant 4. That's what that's going to mean to you. Right? Okay, so let's go down here. Let's go down here to this guy. Arc sine. Now, I see an arc sine. That means I have an inverse function. Okay? So I think this. This is how I think. Here's my sine curve. I can't round to my sine curve. I cut it. I cut it. Aaron, which quadrants am I therefore going to use for my sine?
Sine?
The one we just did. 1 and 4. So, I can either be in 1 or 4. 1 is a positive, 4 is a negative. Which one do I want? Negative. So, I don't want this one, I'm here. Now I label it the way I normally do. Y over R. Y over R. This guy, what angle do I have as a reference angle? 30, because this is my special triangle that we all remember. Now, I have to name this angle. But this angle, remember, can only go from negative 90 to positive 90. Negative 90 to positive 90. So how would I name that angle? What angle in my restricted domain has a sine of negative 1/2? Thirty would put me over here. Negative 30. You can't go all the way around because I can only be from here to here. So is it negative 30 in my allowable domain? So negative 30 or negative pi over 6. Because my domain can only go from negative 90 to positive 90. So if I was to do my 360 minus 30, that puts me out of my allowable domain, 330. I can't be there. I can only be from here to here. So as soon as we restrict the domain, we're going to say, okay, where does that leave me? What quadrants? You're always going to end up with 2. One will be positive, one will be negative. And then we're going to work it from there. Okay? All right. Let's try your cosine. Yes. Negative 30 is your answer. That's the angle whose restricted sine is negative 1/2.
Okay, so is the domain the same thing as?
The domain tells me where sine can look. Sine can only look from positive 90 to negative 90, right here in 1 and 4. Your angles can only go from negative 90 to positive 90. So I have to use the negative 30 here.
If the domain changes, does it change if I use the positive 30?
It will actually, your restricted domain goes here. I don't know if I'm understanding what you're asking me. And we need to be here. We can't use this angle, 330. It's not within that number. So if you're in quadrant 4, Shelley, you have to use the negative number. That's all that means. Did I answer your question?
Yeah.
Okay.
So you can't just put in the calculator
calculator and
You can't.
I mean you could.
Well,
but
for this one, you can
theoretically.
Yes, you can. Yes, it will give you your true inverses.
Yeah.
So now, if you put that in, second
Because
sign
you still
negative
get
1/2,
30, yeah.
it gives you negative 30. And that's exactly what's happening. It doesn't give you 330.
Yeah.
You said, give me the restricted domain angle. Your calculator can only give you restricted domains. Now, we know it as 330, it from 0 to 360. But because our restricted domain now goes from negative 90 to positive 90, we kind of have to change our way of thinking. Right? That's why I'm saying this is a hard concept to get because that angle is a 330 angle, but your calculator isn't going to see it like that. It's going to restrict its domain first.
Now will they give you a different fraction besides 1/2?
No, it still stays 1/2. It's that part will never change.
So it could only really be negative 1/2 or positive 1/2 if we ask
For a 30-degree reference angle?
Yeah.
Yeah.
Would they say like take the arc sine 4 over like 3 or
They
something?
could do radical 3 over 2.
Oh, they do.
Yeah, and then you'll have a 60 degrees reference angle. Oh, it stands for all your angles.
They make it like not a special chart.
Oh yeah, that could be too. Yeah, absolutely. Put in your calculator, second sign, 1 over 3.
Oh,
And it will give you a 0 to 90. If you put negative 1 over 3, it will give you a negative of that angle.
okay.
That's all that.
So you could always check the number.
Absolutely. Absolutely. Okay, now, your cosine curve. Your cosine curve goes like this. Here's your degrees. Here's your pi. Here's your 2 pi. Your cosine curve starts here, goes down, goes up. Right? This is your cosine curve. Now, we always start in quadrant 1. So we start at 1. Whoa, I can't go backwards on this one, can I?
No.
No, I failed. So we stop right there. Now, we continue going until we have to round the bend. Whoops, right there. Gotta stop. So now, where is my restricted domain for cosine?
0 to pi.
0 to pi. Now see if this makes sense. In quadrant 1, I am positive. In quadrant 2, I am negative. Right? For cosine. This is different than your sine curve. So now, I'm in quadrant 1 and quadrant 2. So if I'm looking for a cosine, restricted cosine, I'm either going to be here or here. Quadrants 1 or quadrants 2. And your calculator is going to do the same thing. It's going to do second cosine 1/2, give you a 60-degree angle in quadrant 1. Second sine 1/2. If you do second cosine 1/2. Second cosine, you'll be a 60-degree in 1. If you do second cosine negative 1/2, what angle will you be in quadrant 2? If you do second cosine negative 1/2, what angle will you be in quadrant 2? If you're a 60 in quadrant 1, what angle will you be in quadrant 2? 120, because that goes from here to here. So this guy is giving us 120. Try it. Say second cosine negative 1/2. See if it gives you the 120. Your calculator is a smart little thing. It only does restricted inverses. So like Allie said, could I check it on my calculator? Absolutely. Okay? Let's jump down to this example for cosine. Okay. I want to find an angle.
That triangle would have been in quadrant 1 or 2.
The negative one,
It was negative.
it would be in 2.
Just making sure.
Okay. Our cosine is positive. So I think about my cosine curve. Everybody's positive in quadrant 1, right? Cosine is negative in what quadrant? 2. So since I want the positive one, what quadrant am I? 1. And an easy way, everybody's positive in quadrant 1. So my restricted domain is this to this, 1 and 2. but I only want the positive. So I'm x over r. What reference angle am I? 45. Therefore, what angle is this equal to? 45. I'm in quadrant 1, right? I'm in quadrant 1. A 45-degree reference angle. So my angle has to be 45 degrees. Make sense? If it said this, what quadrant would you be in for this guy? 2. You'd be the same reference angle, but my angle would be what? It goes from here to here. 135. 180 minus 45. 135. And see if your calculator does that. Second cosine negative 1 over radical 2 will give you 135. Good? Okay, one more. Tangent curve. Let's jump up to your tangents. Okay, now, your tangent curve is kind of nice. Because your tangent curve goes this way. Kind of, there's that little segment. Well, okay, yes, it keeps on going. Yes, I realize that, but. We always start in quadrant 1. So from quadrant 1, where will we travel to? We can't break over this one because won't that make us fail a horizontal line test? Right? So we always start in quadrant 1. Well, where am I going to go? I can't go here. I can't go across. Where do I go? Down into what quadrant? 4. Does this little segment right here pass a vertical and a horizontal line test? Tangent makes its own little, the period of tangent is pi. It makes its own little thing right here. So it uses quadrant 1 and it uses quadrant 4. There's your negative. So its restricted domain is negative pi over 2 to pi over 2, just like the sine curve, but the only difference here is you can't use the 90s because there's no tangent at 90. So we put soft brackets on this. And what's my range for the tangent curve? All real numbers. So I'm okay with my range. That's not going to change. So I'm still using, just like your sine curve, 1 and 4. So if I say this, arctan negative, sorry. Yeah, I'm using that. I want to find an angle whose tangent is negative radical 3. What quadrant will I be in? 4, where my negatives go. Tangent is my y over x. I'll put a 1 here. What's my reference angle? 60. My reference angle is 60, so what's my angle that satisfies this? Negative 60. I can only go from 90 to negative 90. Okay? So what you have to do is you have to visualize your curves. Just restrict your domain. You're going to get 2 quadrants. One is a positive, one is a negative.